Hi, this is Christopher Boucher, and I'm going to review a Venn diagram and how it relates to a conditional probability example. Okay, we'll get started. The probability a person entering a car dealership will purchase a car is 0.10, or essentially 10%. The probability the person will buy a truck is 0.05, and 0.01 that they will buy both. What is the probability the next person to enter the dealership will buy a car or truck, buy a truck given they bought a car, or buy neither? Okay. So with any type of probability question, the words matter in this case, and the or is very important, and the given is very important. Neither is just neither, but given is very important for what we're working with, and the or. Okay, so buy a car or a truck. So if we were to roll one die, take for instance, and somebody said to you, if you will win if you roll a 6, then we're just looking for the 6. But if they said you'll win if you roll a 6 or a 5, I'm trying to point out the or, then your probability increases. So whenever we have an or, our probability increases, and that represents the addition of probabilities. So, okay, let's sort this out. So we're going to write down the probability of buying the car, and that is 0.10, and then the probability of buying the truck is 0.05. Now, in this case, we're not looking for both, so we have to subtract both. Otherwise, we're going to overcount the middle. We're actually double counting the middle if we don't subtract the middle in this case. So we end up with an answer of 14.14, or 14%. Make sure I'm on the screen. Okay. So for the next one, buy a truck given they bought a car. So given's a very important word. Whenever we see given, it restricts our space to work out of. So it brings down the total probability space down to whatever it says after the given. In this case, it's saying that the person bought a car and then they turned right around and bought a truck. It's not that they're buying both of them at the same time, but they bought one before the other. I know that maybe it's not a perfect example with cars and trucks in this case, but the given will still work just fine. Okay, so to do this one with the Venn diagram, I'll show you how this works. The easiest way to do this with the Venn diagram is to do this. We put both on top of the restricted space, which is the car. And it makes sense because our car is what it has to be. Our selection is within the restricted space of the car. So it ends up being, just making sure that I don't write the wrong answer here. So this is our probability fraction, and when you work it out, it just ends up being 0.1. So that is a 1% probability that they buy a truck given they bought a car. Okay, and then neither. So neither is it works well with the Venn diagram as well. So with neither, what we do is we always have to subtract something from one when we're working with neither. So neither looks very similar to buy a car or a truck. It's like this: 1, subtract. I almost wrote that wrong. So we're putting in the car, and then we're putting in the truck. I'm writing it kind of ugly. I'll rewrite it in just a sec. And then we're subtracting the middle. So we have car, truck, subtract the middle. And then we subtract it by 1. So I'll rewrite this just a little bit better and scoot this up. 1, subtract the car probability plus the truck probability, and then subtract 0.01, because otherwise we're actually counting the middle twice. So we want to count the middle, we just don't want to count it twice. So when we work this all out, we have the same type of answer that we had with the car or the truck, except we're subtracting our 14% or 0.14 from 1. And so we end up with 0.86, or written as a percent, 86%. Okay? Thank you for watching.